Mathematics in the primary classroom, presentation on a mathematical problem. How can I lower my environmental footprint? The world's population is forever expanding. How can the Earth provide us with everything we need? Your environmental footprint is the scope of your individual impact on the environment. It can be explained by determining the amount of the Earth's surface is needed to provide each of us with water, food and resources. Today for our problem solving we are using a Collette 4-stage model. 1. Understand the problem. 2. Create a plan for solving it. 3. Carry out and perform your plan. And 4. Is a reflection. Step 1. Understanding the problem. What is the problem? What are we trying to work out and do? And what is the information we don't know? Okay, today we're looking at energy. Public transport to work versus driving a car. Cars are the largest contributor to air pollution in the world, affecting the environment. Our personal cars contribute greatly to global warming. Impacts such as extreme high temperatures, serious droughts, flooding and rising seas are becoming more common. Air quality. These dangerous pollutants cause smog and can cause respiratory problems and lung damage. Purpose of investigation. Which means of transport to work is going to lower our carbon footprint between a car and a bus. What costs and emissions can be saved? Okay, so here you can see an Australian average household emissions pie graph in tonnes per year. You can clearly see that 49% of emissions are caused from transportation. Purpose of investigation. We want to reduce our carbon footprint by reducing the cars on the road. So in the first graph we can see that 80% of people drive their car to work, and in the second graph the top 5 ways Australians get to work is by car. Over 6 million people travel by car as opposed to just over 300,000 that travel by bus to work. What areas of mathematics will we be exploring to link to our problem? Multiplication, subtraction, decimals, money, algebra, data representation and interpretation. We will use these areas to establish and compare the cost and carbon emissions of cars and buses. We will also use these concepts when looking at distance and graphs. You will be required to do your calculations by writing them out, but you can also check your answers with the use of a calculator. Step 2, making a plan. What information do we need? I've also created a few tables here. Making a plan. So for expenses, I found out that the average medium-sized car costs 78 cents per kilometre to run, and that is inclusive of petrol. I've also found out that a return bus ticket to work per day is $4.80. Okay, so I've done a quick table of expenses. So you can see the bus costs $4.80 per day, and the car costs 78 cents per kilometre. But we haven't found out what the cost per day is for the car, so we'll find that out later. Both cars and buses travel 10 kilometres a day, 5 days a week, at 48 weeks of the year. Carbon emissions. Okay, I've got a graph here that shows that cars emit 205 grams of carbon dioxide per kilometre, and buses emit 186 grams of carbon dioxide per kilometre. I've also done a table of emissions here, so you can clearly see bus and car. Okay, we also need to note that 1 kilogram equals 1,000 grams because we will be doing some conversions with our calculations. And weeks per working year, 52 weeks minus 4 weeks annual leave is 52 minus 4 equals 48 weeks. Step 3, carry out the plan. Perform the strategies that we have selected until we solve the problem. Carrying out a plan, expenses for the bus. So we know that a bus ticket costs $4.80 per day. So we need to times $4.80 by 5 days, that equals $24 a week to catch the bus. So over 1 year, that's $24 times 48 weeks equals $1,152 a year to catch the bus. Okay, so for the car, we've got 2 steps here. First step, we need to multiply the cost of running the car by kilometres. So 78 cents per kilometre times 10 kilometre equals $7.80. Step 2 multiplies $7.80 by 5 days, so that equals $39. So now we need to do 1 year. So we need to multiply $39, which is 1 week's cost, by 48 weeks. So that gives us $1,872 per year to run the car. Okay, so now we need to subtract the bus cost from the car, so that's $39 minus 24. So that gives us a saving of $15, sorry. So we save $15 per week by catching a bus. Now we need to work out the yearly savings. So we subtract the bus from the car again, so that's $1,872 for the car minus $1,152 for the bus. So that equals $720. So therefore we save $720 per year by catching a bus. Alternatively, we could also multiply our weekly savings by the number of weeks. So that's $15 by 48, and that also totals $720 for yearly savings. Now, I've done the yearly expenses in the graph here, so you can clearly see the car in yellow and the bus in the maroon. So once again, we're saving $720 per year by catching the bus. Now, carbon emissions for the car. So we know that our car emits 250 grams per kilometre, so 205 grams per kilometre. So 205 grams by 10 kilometres equals 2,050 grams. Step 2. Multiply 2,050 grams by 5 days, so that gives us 10,250 grams. Now we want to convert this to kilograms, so we need to divide this number by 1,000. So that's 10,250 divided by 1,000 equals 10.25 kilograms. So per week the car emits 10.25 kilograms. Now the yearly car emissions is 42 weeks times 10.25 kilograms. So that gives us 492 kilograms of carbon per year. Okay, so for the bus, so we know the bus emits 186 grams of carbon per kilometre. So 186 grams times 10 kilometres equals 1,860 grams. So step 2, multiply 1,860 grams by 5 days equals 9,300 grams. Now convert this to kilograms, that's 9,300 divided by 1,000 equals 9.3 kilograms. So the bus carbon emissions per week is 9.3 kilograms. Now per year, we times 9.3 by 48, and that gives us 446.4 kilograms. Okay, so now we need to subtract the bus from the car. So 10.25 kilograms minus 9.3 kilograms equals 0.995 kilograms. Now we can convert that to grams, so we'll times that by 1,000. So 0.95 kilograms times 1,000 equals 950 grams. Therefore, we save 0.95 kilograms or 950 grams of carbon emissions each week by catching a bus. Now the yearly emissions, we subtract the bus from the car, so 492 minus 446.4 equals 45.6 kilograms. Convert that to grams, we go 45.6 grams times 1,000 equals 45,600 grams. Therefore, we save 45.6 kilograms or 45,600 grams per year by catching a bus. So I've done a carbon emission graph up for the year, so you can clearly see a car versus a bus, and we have reduced our carbon footprint by 45.6 kilograms per year by catching a bus. So our solution is right and correct, and it does make sense.